This is grade 7, module 12, lesson 2. Our I can statement for today is I can use proportional reasoning to make inferences about populations based on the results of a random sample. So here we have a random representation survey of 100 7th graders in Washington Middle School, and that shows that 20 students read 5 or more books over summer. If there are 275 7th graders at Washington Middle School, based on the sample, okay, so just based on the sample results, how many 7th graders read 5 or more books last summer? So what we're going to do is set up and solve a proportional relationship between the sample and the population. So here we have the sample. So students who read 5 or more books to the total number of students, and then we're going to compare that to the school. So we're comparing the 7th graders to the school. So we have our school here. Oops, wrong color. So here we have to the school. So we end up with a proportion like this, where we have 20 over 100, so 20 over 100 equals x over 275. So we have our part over our whole, and we're comparing what we sampled to the total. So one thing to be really careful about is your part always needs to stay in your numerator, and your whole always needs to stay in your denominator. Okay, they have to be the same across. Okay, you don't switch them like that. So to solve this, we need to use some cross multiplying. So let's zoom in here just a little bit. We're going to do 100 times x, 275 times 20, and that's how they get this here. And then in order to get x by itself, you need to divide both sides by 100 because x is multiplying. The opposite of multiplying is dividing. What we do to one side, we must do to the other. And let's see, 100 over 100 is 1, so that's great. That's what we want. We want a 1x, which is what we have here. Cancel those out for 1. And 5,500 divided by 100 will give us 55. So x equals 55. To put that into a sentence, remember to always follow what you're solving for. So we have x equals 55, but 55 what? What this is saying is that based on the sample results, so just this sample, 55 7th graders at Washington Middle School read 5 or more books last summer. So based off of this sample, okay, the sample here, that 55 7th graders out of the whole school read 5 or more books. Okay, so let's set up some more proportions here. So Olivia randomly samples 50 students attending a basketball game and asks what grade they are in. Of the students surveyed, 19 were in the 7th grade. Okay, so highlight that. If there are 200 students attending the basketball game, based on the sample, how many are in the 7th grade? So we had 19 out of a randomly sampled 50. And then there's a total of 200 students attending the basketball game. So we need to set up our proportions. So we're going to have 19 over 50. So that part over the whole, the total there, is going to equal what out of the 200 attending the game. So we have our part over our whole there. So the whole amount is in my denominator. And then, sorry, that's a really bad little arrow there. Oh, there we go. And then our part. So we're trying to figure out of the 200, knowing this is randomly sampled, what amount are seventh graders. So let's try and solve this here. We can do our cross product, or we could figure out what the relationship is between these two proportions. 50 times what will give me 200? 50 times 4. And then what you do to the bottom, you got to do to the top. So 19 times 4, pause your video, and that'll give us what our x value is. So x will equal 76 students, but let's put this into a sentence here. So out of the 200 students, 76 are seventh graders. So 76 seventh graders. Or 76 are seventh graders. All right, Noah assigns a number to each of the 150 athletes at his school and puts the numbers in a box. He randomly chooses 30 numbers and finds that 18 of the athletes watched television last night. Use the sample to make an inference about how many athletes watched television last night. So we need to set up our proportion. We're going to have our random sample. So we have a total of 30 and then 18 watch TV. And then our total is out of 150. So we're going to have our 18 over 30 equals what over 150? Okay, so 30 times what will give me 150? And then what you do to the bottom, you do to the top. Figure that out. Pause your video, unpause it when you think you have the answer. So we have 30 times 5. And what you do to the bottom, you gotta do to the top. So that means x equals 90. Now to put this into a sentence, that's gonna mean 90 athletes watched TV. All right, last one. A manager at a factory finds that in a random sample of 250 watches, 3 are defective. Okay, so there's our random sample. 3 are no good. And then we have a total of the 7,500 watches. Of the 7,500 watches from which the sample is chosen, about how many watches are not defective? Ooh, not defective. So we're actually going to be finding which ones are defective. So that'll be an extra step at the end there. So let's set up our proportions. So we have 3 out of 250, not too bad odds there, equals 7,500 over x. You could try and do this method. 250 times what gets 7,500. What you do to the bottom, you do to the top. However, that doesn't always work, so it's good to know how to use your cross product. So we're going to do 250 times x equals 3 times 7,500. Pause your video. What is that going to equal? Unpause it when you're down to that answer. So we're going to have 250 times x equals 3 times 7,500. When we multiply that out, 3 times 7,500, it's a nice big number here, 250x equals 22,500. And then we're going to need to divide by 250 on both sides. And that will give us x equals 90. Now, is 90 your answer? No, 90, we're talking about these are the numbers that are defective. And we're trying to find the ones that aren't defective. So we have to do some subtraction. So 7,500 minus that 90 means that 7,410 are good to go. They are not defective. So our answer for how many watches are not defective, 7,410 watches.